Domain and range. So domain and range are just definitions to describe values of x and values of y in a certain graph. And so you kind of have to remember those as definitions. And one of the ways I do that is to tell a little story about a dachshund. So dachshunds can only travel back and forth. I mean, they might try to jump a little bit, but really they're going to walk along this horizontal distance. And so I named my little dog, this is a dog. I actually put Woof here so you could tell he was a dog. I named him Dox, D-O-X. And that D-O stands for domain, and the X stands for the X values. And then our Y-axis, I have Ray. So I have a sun right there that I'm calling Ray, and Ray is for range. So the R-A is for the range, and the Y is for the Y value. And so when I talk about range, I'm talking about the Y values. When I talk about domain, I'm talking about the X values. So range vertical is a Y, and that RA stands for range, and the Y is for the Y axis. And domain is X, so dox, D-O stands for domain, and X, so it's horizontal, X stands for the X axis. And so that's what we're going to be using when we're describing our X and Y values and what they can be. So let's start with a table. So in a table is pretty easy to identify what the X values and what the Y values are. So domain and range in a table. When we look at our X values, we can see they take on -5, -3, -1, and 1. So we don't know if this is describing something bigger. If we're just telling the domain of this table, we would just list them out. And these little curly brackets are just set notation. So for our domain, X is equal to -5, 3, -3, -1, and 1. And our range are just going to be our Y values, 7, 8, 9, and 10. So we've got now over here, we've got our X values always giving us the same Y value. So it's always equaling 3. And so we don't write all of these 3's for our range. We just write the 3 in the set notation. We don't need to write all of the 3's in there. It just can take on the value of 3. So our domain here is just right here, -1, 2, 3, and 4. And our range are just our Y values, our Y values, just to 3. Let's take a look at some graphs. And when we use domain and range, we can write it several ways. We can write it as a list, like as a set. We can also write it using inequalities, and then some special ways to write it when it's infinite values. So here's a graph right here. You don't have to know what equation makes that graph. You can just take a look at that graph. Now let's look at our domain. So our domain right here, what values can X take on? So if you imagine the little dog walking along our X-axis right here, can he look up and find a point on the graph anywhere he goes? Look up or down. So as he walks along, yeah, even if he goes infinitely this way, this goes on forever, he'll be able to find that graph if he can just look straight up. So he's walking along, and all the way over here. So X can be any value, and we're going to be able to find what's on the graph right here. So our domain is all real numbers. We can also write this a special way. So we can write this as a fancy R, and really it's just 2 lines and then an R. Our range, however, if we're shining rays down here, we're only going to be able to go to here, because you can see down here there are no Y values in this graph, so there's nothing in the negative area. And so we're going to write this as Y is greater than or equal to 0. So this is a place where we use inequalities. Now let's take a look at this other graph. So if we're imagining walking along as our little dog, we can only go from here to here and have pieces of the graph. So we can look like right here is okay, here's okay, here's okay. Once we step past here, we have no more values. And so over here at -4 and all the way to 4, we're going to be able to find values on the graph. So our domain is going to be -4 is less than or equal to X, which is less than or equal to 4. So X is sandwiched between 4 and -4, and we have an inequality that shows that. So it's simultaneously greater than -4 and less than +4. Now our range, we do the same thing. If we look up and down right here, we can go from -2 to 2, and it's all these values in between. I'm going to be able to find stuff on the graph. And so our range is going to go from -2 is less than or equal to y, and I'm going to use y because I'm talking about range, which is less than or equal to 2. So those are my values of the graph that I can find on here. So if I found a -1 right here, I could find 2 places right here that y is -1 on the graph. So let's look at some graphs that we're very familiar with as lines. So if we look at our lines, for example, this line, y equals 3x minus 5, we can see that if our little dog walks along this x-axis, what values can we find on the graph? And this goes on forever. So no matter how far we go on this x-axis, we're going to be able to touch that graph down here. And the same is true over here. So our domain is all real numbers. Our range is also all real numbers. It doesn't matter how far we go up or down, we're always going to be able to touch that graph of y equals 3x minus 5. And in this case, we talked about lines that looked similar to this that were a function. So then if we look at this line right here, so here's our y-axis, here's our x-axis, and we have the line graphed x equals -3. So x is always equal to -3. So we can look at our domain. If we walk along here, the only place where that graph is going to hit is x is equal to -3. So our domain is a single value, it's -3. Our range, however, this goes all the way up and all the way back down. Our range is all real numbers. And in this case, if we go back to what we were talking about for functions, this is not a function, because if we choose -3, we can get multiple, infinite actually, y values. So let's take a look at this one over here, y equals 2. So here's my y-axis, here's my x-axis, and this is the line y equals 2. So y is always equal to 2. No matter what x is, y is equal to 2. So my domain are all real numbers. X could be anything. And when x is anything, either direction, we know that y is only going to be one value, and that one value is 2. So my range is y equals 2, or I could put it in little brackets right here in set notation and just write a 2. And in this case, this line, this horizontal line, is a function because I can always predict, given any value of x, I know what's going to come out. It's always going to be a 2. Lastly, we're going to talk a little bit, just a tiny bit, about restricted domains. So there are some domains that certain values can't be present. For example, y equals the square root of x. So we know, or maybe we've heard, we can't take the square root of a negative number. So we know our domain has to be greater than or equal to 0. So for example, the square root of -4, there's no real number that's going to make that true. If we try 2, 2 times 2 is 4, not -4. If we try -2, -2 times -2 is also +4. So we can't get a -4, so there's no real solution here. If we look at something like this is a little bit trickier. We have 5 over x minus 8. And the thing to look at here is we know we can't have a 0 in the denominator. Now, why can't we have a 0 in the denominator? Well, say we had 5 over 0. That's impossible. Because what times 0 is going to give you 5? Nothing. You can't think of anything times 0 that's going to give you a 5. So it does not exist. That's what this D and E stands for, is it does not exist. We cannot do that. And so here, our domain is all real numbers except x cannot be equal to 8. Because if x were equal to 8, 8 minus 8 is a 0, and then we would have 5 divided by 0. And so this is just a sampling, a small sampling of restricted domains.